Greetings, fellow mathematicians! We're going to take a look at another really good question on calculating the derivative f prime of x by using the limit definition. This one is almost definitely going to be a standard Calculus 1 exam question, so you'll want to make sure to fully understand it. Now here, since our function contains multiple x's, the work is going to be a lot more tedious. But again, if you take your time, like we will in this video going through this problem, you'll be able to get through it. All right, now if you're finding yourself having trouble getting started, a video linked down below in the description with some tips that we mentioned and from the steps and tips for the limit definition of a function at a point, those still apply. And one of the tips we mentioned in there to help you get started with this, in case you aren't sure how to plug in x plus h, just take your function and replace all x's everywhere with an open set of parentheses. And that's going to make it a lot more obvious where to plug in step 1, x plus h. So let's go ahead and do that. And we're going to break this complicated question down into several simpler, easier steps. All right, step 1, we're going to take our function and plug in x plus h everywhere. So that's going to go in 2 spots because we have 2 x's, an x squared and an x term. All right, so we're going to calculate f of x plus h. Go ahead and replace that. We're going to get 2 times x plus h squared minus 3 with a set of parentheses times x plus h. And then we have plus 1. All right, be careful here. You're going to want to properly multiply out the x plus h squared term. Let's go ahead and correctly FOIL that. I'm going to keep the factor of 2 out front. Again, we are taking our time with this, so that way you can be successful with this on your own. All right, so expand, multiply x plus h squared. You'll get x squared plus 2xh, right? Don't just square x and h. And then you'll get plus h squared. And while we're at it, let's go ahead and distribute the negative 3 through the parentheses there. So we'll get minus 3x and then minus 3h and then plus 1. All right, now let's go ahead and distribute that 2 through the parentheses. And it looks like what we'll get is 2x squared plus now 4xh plus 2h squared. And all the other terms, minus 3x minus 3h plus 1. All right, and typically here in step 1, there's not a lot of terms that can be combined. So that's pretty much it. There are no like terms. We can move on to step 2, which is now calculating the difference of this expression where we're subtracting f of x. Now, since our function contains several terms, we're going to want to use parentheses. However, just to make sure you're aware of a common mistake that many of you might be making, let me go ahead in the next step. Let me make an intentional standard mistake. All right, and the mistake is going to be due to not properly using parentheses or forgetting about that fact that we're subtracting there. All right, so again, this will be a mistake and then we'll fix it. So let's write this as f of x plus h minus f of x. These problems are tedious, so first for f of x plus h, we're just going to write all those terms. Make sure you're taking your time with that and you're careful to copy all of them down. So we have 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. Those are all the terms for f of x plus h. Now we're going to subtract. And again, I'm going to make an intentional mistake. So we have minus, and what we're subtracting is f of x, right? And there's our function, f of x. So we're going to have minus 2x squared minus 3x plus 1. And there is a mistake. It is probably the most common mistake that can be made through this problem. The other common mistake is right here, squaring x and h to get x squared plus h squared. That's the other typical mistake made here. Now here, the problem is we are subtracting something with several terms. So the mistake is that negative really should distribute to those terms and change all the signs. The way we fix that, with a very important tip, use parentheses. So we're going to fix that here, and I'm going to put a set of parentheses around the f of x term right there. And again, using parentheses, that is probably the best tip I can give any student going through the calculus sequence. All right, now let's go ahead and just write down all the terms, correctly accounting for that minus. Again, this is a simple problem that we're going to be using in the beginning of a Calc 1 course. So we're going to go through all of the steps at a slow pace. All right, so let's simplify this. I'm just going to copy all those terms down. I want to make sure you see which terms cancel out. So we have 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. And now we're going to distribute that negative sign through the parentheses. All the signs inside of your f of x term there, they're going to change. So we're going to get minus 2x squared plus 3x and then minus 1. All right, now if you did forget about the subtraction sign there and forget to use parentheses, you might have been able to find that with your check here in step 2. Once you go through and fully simplify that, all terms that remain should contain h. And had you forgotten the parentheses there, you would have found that there were terms left without h, giving you a hint to go back and check your work for a mistake. That's almost always forgetting about using parentheses. All right, so now let's go ahead and see if our check is met. We should have a lot of terms that cancel out, and let's take them term by term. We have 2x squared. That cancels. Looks like we have minus 3x and plus 3x. That'll cancel to 0. And we have plus 1 and minus 1. All right, and what we're left with, 4xh, that contains h. 2h squared, that also contains h. And minus 3h, which also contains h. Let's just go ahead and write them down. We have 4xh plus 2h squared, and then minus 3h. And like our previous problem, problem number 1, because all of our terms here contain h, you can factor h out. So let's go ahead and do that. And what you should be left with here is in the parentheses 4x. Middle term here, factoring one factor of h out, you'll be left with 2h. And then your last term here in the parentheses, you should get minus 3. And always go through a quick check here when you factor terms out. If you distribute h back in, you should get to here, which we do. All right, now we are practically done. Don't forget, and I've seen many Calculus 1 students go through all this work and forget about step 4, we now take a limit as h approaches 0. All of your work right here is going to lead, when you go ahead and divide by h, to the indeterminate form canceling out. Let's go ahead and write that down. Step 3, f of x plus h minus f of x. We're going to divide that by h. And what we're dividing by h is the end result of step 2 here. So we had that as h times 4x plus 2h minus 3. And now we're dividing by h. And it's at that moment that the indeterminate form cancels out, allowing us in step 4 to evaluate the limit by plugging in h equal to 0. And what we get here, for not our limit yet, but the end result of step 3 is 4x plus 2h minus 3. And now if we go ahead and write down what we're calculating, this is f prime of x, the derivative of our function, which is defined as the limit as h goes to 0 of this difference quotient, which we just simplified here to 4x plus 2h minus 3. And again, because the indeterminate form cancels out, you can evaluate this limit by plugging in h as 0. And you get as your answer, remember, you typically should expect a function of x for your answer here for the derivative of a function. The derivative of a function at a point, that comes out to a number. And we do get a function of x here, 4x minus 3. And that is the derivative of this function, f of x equals 2x squared minus 3x plus 1. All right, let's just go ahead and write down the function and the derivative, just so you see some patterns here. So our function was 2x squared minus 3x plus 1, and we just calculated the derivative, f prime of x, as 4x minus 3. And there we go. Again, this problem is occurring in the beginning of your Calculus 1 course, and very likely immediately after this, you'll be getting to some of the rules, the shortcuts, for calculating derivatives. The power rule, sum and difference rule, as well as coming up, product and quotient rule. However, this video, we're focusing on the limit definition. Hope you enjoyed the problem. Hope you're learning a lot. If you are, support the channel, like and subscribe.